Hello, I will show you the contents of the main box. So the Tamiya F4 from Horizon. The first box contains the accessories. Then you have all the materials to decorate the car body that you can set aside. And finally, at the bottom of the box, you have the car. In the largest of the boxes, you will first find a bag containing some accessories. The 4 cartridges too. That need to be filled beforehand, before use. The 2 pressure regulators. The screwdriver that will allow you to mount the cartridges on the car, and 2 bags of spare parts that are there to replace any potential losses of screws or nuts, but which are not necessary for you. The only necessary element will be these tubes to make the connection of the hydrogen circuit. There you go. The rest you can set aside, and you have some spare parts in case of loss. Now we can take the car out of the main box. As you can see, the car is wrapped in a hermetically sealed plastic bag. We strongly recommend putting the car back in this plastic bag after each use to prevent the hydrogen cell from drying out. So, we are going to take the car out of the bag. Above all, keep this bag to put the car back in. You can remove the bodywork, which you can decorate if you wish, with the stickers we saw at the beginning. There you go. In front of you, you have the new F4 from Horizon. Let's now take care of the second and last box we found in the main crate. You will find the remote control, which is paired with the chassis. If you have multiple chassis, make sure not to mix up the remote controls. The 9-volt external power supply that you will need for using the F4. The quick charger that will allow you to recharge the car's battery, which is already placed in the chassis. The documentation for the remote control. You will notice that with its documentation, you will also find a micro USB cable that will allow you to charge the remote control, as this type of remote control does not operate on batteries, but on a rechargeable battery via a USB connection. You will find a piston, which is a very important part for system calibration. So above all, identify it and keep it. Finally, you will find a bag of clips and staples that will allow you, if you wish, to replace any lost staples on the car or to attach the body if you decide to cut it to mount it. There, we have emptied the second box. You now have in front of you all the elements you need to identify in order to implement your F4 from the first plastic box you received. We will now complete the assembly of the hydrogen part of the car. For this, you need to take one of the pressure regulators. Unscrew the nut. Remember to insert the drilled nut onto the tube first, then mount the tube. On the regulator, making sure to push it all the way to the stop. You see that the tube must go all the way to the stop against the threading of the pressure regulator. Once you have properly mounted the tube, you can screw the nut. Tighten without excess, because in fact the tube will serve as a seal, so you need to slightly crush the tube. But if you crush it too much, you risk cutting it. So, you need to tighten reasonably to avoid any leaks. You do the same operation on the other with the other pressure regulator. We can now take hold of two hydro sticks that you will have previously charged. Screw in the first hydro stick fully. Insert it in the supports, then secure it very lightly using the Phillips screwdriver provided to you. As long as you use the car on the bench, it is not necessary to tighten enormously the hydro sticks. If you decide to race on the ground, however, obviously, we advise you to tighten a little more firmly, but do not crush the tube too strongly either. Just enough to hold it so the hydro sticks don't move anymore. There you go. We still need to establish the connection between the battery and the vehicle. Here you see a male DIN connector, the female connector of the battery. And by paying attention to the polarity, you can establish the electrical connection. Be careful, from that moment on, the car is powered and is sensitive to any short circuit that could be unintentionally made. For using the F4, you will of course need the remote control. Check before use that it is fully charged. Here we see that it is not fully charged. So, if you wish, we recommend using this micro USB connection with the provided cable to complete the charge of your remote control and avoid any issues during the session. Once this is done, you can set the cable aside. So to remove the battery from the baby F4, simply disconnect the DIN connector securely. Then you have a retaining bar with two circlips, one of which is easily accessible. Remove the right clip. We lift the rod that can be rotated to simply access the battery. So when the battery is discharged, we charge it using the quick charger that comes with the system. Be careful, is a charger available for several battery models: LiPo, Life, or NIMH. In our case, it's a NIMH battery. So before connecting the battery, you need to select the type of battery being charged. We power it very simply with the cord provided. Then you have a second cord that allows you to charge batteries, but with a different connector. You have a connector that you cannot plug in the wrong place because there is a 3-point side and a 4-point side. So then, when you start the quick charger for the first time, it is set by default for LiPo batteries. To select NEMA, press once on NEMA. The LED turns red above NEMA, and you can connect the battery. We connect the battery, always paying attention to the polarity. Once the battery is connected, it does not charge automatically. You need to hold the NIMH button for about 2 seconds. There you go. It starts blinking, which means the charging has begun. The charging lasts about 2 to 4 hours, depending on the initial battery level. Now, we are going to open the second box, the heaviest one, which contains the test bench. So this box should be handled with great care. Avoid impacts, as it contains metal masses that can damage the system. It also contains very sensitive pressure sensors that can be damaged if this equipment is handled too roughly. Let's open the box and carefully remove the test bench. Place the bench in front of you. By showing the braking system, the eyes on your right, and the matter observer, the matter side on your left. As we can see, this bench consists of 4 rollers simulating the vehicle's inertia, coupled together. You can also see here a force sensor that will measure the car's thrust. Be careful, this sensor is fragile. Avoid pressing too hard on this sensor to prevent damage. Here you see a braking system using a servo motor that will simulate an uphill effort on the car. Finally, you can see 2 connections that need to be made to link the bench to the car. Let's start by mounting the car onto the bench. Take the car, if possible, either by the pins or by the chassis. But at some point, you will be hindered. In a word, above all, do not take it by the electronic boards. You can also take them by the cartridges, but again, especially not by the electronic parts. The best way is to take it by the rods, because you will first be able to insert the front of the car, place the front of the car on the rollers, and push the front of the car until you can insert the rear bumper. At that moment, you can check the correct positioning of the car. The play should be 1 to 2 millimeters, no more. At the back, the car bumps its bumper against the bench. The stop is clear. Now let's make the last 2 connections before we can operate the system. These are the connections between the bench and the car. Indeed, it is the car's electronics that will perform the acquisition of the measurements taken by the bench and will control the braking system. The first connector that leaves no ambiguity is the 3-point connector. You only have 1 3-point connector left, and it is on the right of the board, right next to another 3-point connector. So, you can make the connection without risk and without possible error. The second is a bit more delicate because you have 2 4-point connectors left, and your connection requires 4 points. You need to choose the connector that is right next to the one you just connected and leave the next 4-point connector, which is on the left of the board. That one is for another use. Let's now proceed to start the car on the bench. We have previously placed the car on the bench, checked that it is properly positioned, and that it presses on the force sensor at the front. First, let's check the tightening of the 2 pressure regulators to avoid any leaks with the hydrogen tanks. Secondly, let's establish the battery connection by the 2 available DIN connectors, male and female. Instantly, you see this red LED light up, indicating the presence of the battery. Then, you connect the external 9-volt power supply of course, connected to the mains. What is this power supply for? This power supply will allow you to power all the car's measurement electronics as well as the brake servo motor completely separately and not take their power consumption into account in any balance calculations you may do, following the measurements taken on the car. We have connected the battery, connected the external power supply. You can see the external power supply by a green LED that is currently blinking faintly. All that's left is to actually start powering all the electronics with the battery. You do this by flipping the battery switch located on the protection plate labeled battery. The on position is the outward position. The green LED is now lit much more prominently and steadily. This means that the board and the cards are powered and the different processors are starting up, notably the Linux server. We must now wait for the server to finish booting by observing the control PC, and when we are able to establish the Wi-Fi connection on this PC. Last very important thing, during startup, the vehicle performs a zero pressure adjustment on the front force sensor. It is therefore very important not to disturb this zeroing by pressing on the vehicle or installing the pusher too early or in any way disrupting the pressure measurement. You must let the vehicle perform its zeroing, and you are sure the zeroing is done when you see the carrier, the Wi-Fi SSID, appear on the PC. That's what we will see now. After turning on the H cell in electricity with the external power supply, you wait about 30 seconds for the embedded server to finish booting, and the end of the boot is indicated by the appearance of the Wi-Fi connection on your command PC's list. Here we see the syntax, which is always the same, regardless of the version Creatito 2, the serial number of your equipment. You connect on this carrier. If it's the first connection, a password will be requested. This password is T02 in lowercase and altogether CREACREA in uppercase. T02 lowercase, altogether CREAA uppercase. Once you have entered this password, initiate the connection. Once the connection is confirmed, you can now open Firefox to access the server's homepage. The first thing we will do is calibration. So we will not try to access the main page directly, but we will access the calibration page. Please note the address of the calibration page. The most interesting thing is to bookmark it, even if you don't have to calibrate often. We recommend calibrating, of course, the first time you receive the equipment, as it is mandatory to have consistent measurements. Then, it is not necessary to recalibrate unless you want to ensure that the measurements to be taken have the maximum possible precision. For example, before an exam. The wear of the sensor can cause a very slight drift. At that point, we recommend recalibrating. But what is important to understand is that the calibration data is saved in the car and is linked to the force sensor on the bench. So, it is important to maintain the connection between the bench and the car. And, if possible, always use the same car with the same bench. If you need to change the bench or the car, then it is important to recalibrate. So there you go. We call up the calibration page whose address is indicated here. Once connected to this page, here is its presentation. The first thing you need to do to start the calibration is to install the pusher at the back of the car. To install the pusher, you must carefully insert the male rectangular imprint into the female rectangular imprint on the car chassis and gently push the pusher foot so that it hooks into the groove of the bench. Make sure the pusher is in the most orthogonal position possible. It is important not to push too hard, because when you push, you press on the force sensor. And it is important not to exceed the maximum effort. So you push the foot of the pusher just to fit it into the groove. Once you reach the height of the groove, you insert it and gently release, ensuring the correct position of the pusher. Now, your car is pushed by a known force of about 18 newtons against the force sensor. You return to the control PC. You press the first button, or the button for the first step, which will trigger the thrust measurement. The end of this measurement is indicated by this window, prompting you to move to step 2. You exit this window, then press the button for step 2. At that moment, the system should indicate to you that on one hand, it has performed the calibration. The second number here is a figure that indicates the force measurement it performed before calibration. And so, it will normalize this measurement by calculating a calibration coefficient that will henceforth be used permanently for all measurements. Now, your system is fully operational. Last thing, do not forget to remove the standard plunger before any use. Now, the car is fully operational, and you can start any activity.